Hello everyone. We are going to look at now Taiwan's coal allocation problem in association with Artificial Intelligence Foundations and Application. Our team members are Gyan, Prakash, Konhar, Ankit Sahoo, and Job Nandrekar, myself. Gyan is from the Department of Naval Architecture and Ocean Engineering, while I and Ankit Sahu are from the Department of Mining Engineering. Since our departments have included mining and ocean, we are going to talk about a very interesting problem. Uh, Moving on. So we have divided our presentation into three parts. First is the problem statement. We will look at the Taiwan's coal problem. Secondly, we'll look at the planning problem, a solution that we have derived, an approach so that we may solve this coal problem happening in Taiwan. And finally, we look at something interesting called that we have termed as the plan of plans. So let's look at the problem statement first. Right. So Tai Power is the Taiwan's leading power company. It has itself the monopoly in the market in Taiwan. It annually imports around 14 million tons of coal from different countries like South America, Australia, South Africa, Indonesia. So there are around five different coal mining areas from which Tai Power actually brings in coal. Next, this coal is brought into via ports. So there is the Koshungi port, the Taichung port, and the Keelung port. These three ports are there, and according to the requirements of the coal is being transferred to these ports in Taiwan. Moving on. Okay, so we have different kinds of vessels that are coming to these ports, and the vessels contain different kind of coal. So there is bituminous coal, there is anthracite, there is coking coal and non-coking coal. So depending on the requirement of the plants in different locations in Taiwan, this different kinds of coal is being sent by those different ports and to Taiwan's ports. Okay, and also the we can say that the amount of delivery, so the amount of coal that is being required by Taiwan is not limited to a specific number. There is a amount of flexibility limit. So the demand each it fluctuates going up and down. So according to that, we can say that we have a complex problem in front of us. Moving on. So this is the Taiwan's ports. You can see the Tachungi port is in the west, the Kashung port is in the south, and the Keelung port is in the north. So these three ports are the major ports through which all the coal is coming in, and it has to be transported all throughout the whole country of Taiwan. So we can see in the next slide that the complexity of the problem is very much increased because there are multiple ports, there are multiple coal types, there are multiple power plants, there are multiple demand and supply options, there are multiple sources of coal being produced around the world that is being sent to Taiwan. So we need to make a highly efficient decision as to how much coal is being sent to which plant and how much what is the quantity of coal, what is the quality of coal. In order to do that, we have proposed the planning problem that will be explained by Ankit in the next slide.
Okay, so coming to the planning problem, what we have done is that we have divided the planning phase into a set of actions which are necessary for reaching to the goal state, starting from the initial uh, start state. So here we have a couple of variables in the planning problem. Like we have 25 different mining cities or areas where the coal is produced. Different types of coals are produced. We have three types of ports as already mentioned by Job. We have 30 different plants which are producing coal, and also there are four types of coal like anthracite, bituminous, and coking and non-coking coal. To give a realistic twist to the problem, what we have assumed is that the demand of the coal may vary from plus or minus 10%, as it usually happens in the real life. Suppose we are considering a particular plant, say ith plant out of the 30 plants present, and for that plant we have to reach from the start state or initial state of coal alarm to the final goal state of coal satisfied. Now I would be explaining you these two states, the initial state and the goal state, along with the set of 5 actions that is needed to be performed by each plant separately. So the start state is the coal alarm, which means that in the next month, what is going to be the quality and quantity of the coal that is required by a particular plant. And in order to reach from the start state to the goal state, we perform set of actions. So by action 1, we determine the quality and quantity of the coal required. By action 2, we determine the port of the coal, like it can be multi-source or single source. So let me explain this to you, this action 2 to you. Uh, like the demand of coal generated by a particular plant is being able to be satisfied by a particular port or not. Like if the particular port which is nearest to the plant is not able to satisfy, then we move to the next nearest port, and then if it is not able to satisfy, then we move to the third port. So likewise, we are going to determine if the quantity which is demanded by a particular plant is going to be satisfied by one port, or we require two ports, or we require all the three ports. In coming to action 3, we find the minimum distance source, that is MDS, from with the required quality and quantity. That is, we find the nearest city from the particular port which has the desired quantity of the coal and the same quality of coal that is required by the plants. By action 4, we direct the ship from the MDS to respective port. This is just a transportation action that we move to the respective mining area to the desired port. By the last action, that is action 5, we transfer the coal from the port to the plant. Like first, the coal is being deposited, is transferred from the cities to the ports, and from port we are transporting it to the plant. And after performing these set of 5 actions, the final goal state, that is the amount of coal that was required by a particular plant, is now satisfied. Now the set of actions that is going to be performed in each step is going to be explained in a detailed fashion by my friend Gyan. So over to you, Gyan.
Yeah. So, as Ankit said, so there are two things. First, the initial state and the final state that we term as the initial state, that is the start point or the goal. So, in between those, we have various states from state 1 to state 4 or state 5, whatever we have. And to jump from one state to another, we need some action to be performed. So in detail, we'll know what are those things. So here in S initial, we have a coal alarm. So whenever at the destination plant, our coal is going to over or is the limit is going below a certain percentage, before 1 month of that, this alarm will generate a message. And then we'll get to know that the destination plant is getting a shortage of coal in 1 month. So we have represented it as not of at, that is coal is not present at destination plant. I mean, that's about 1 month later. So yeah, to reach S1 state from S initial, we need action A1, that is determining the quality and quantity of coal required at that destination plant. So what is the precondition is, we don't even know the quality or the quantity, how much and what type of coal is required at the destination plant. So after performing this action, the effect will be that we'll get to know about what quantity of coal and what quality of coal we require at that destination plant. So here we reach state S1, that is known demand. So from known demand state, that is S1, we have to go to state S2. So state S2 is nothing but known ports of coal. So action we have to perform is A2, That A2 is nothing but determining the port of coal, and whether if it's multi-source or a single source port. So the precondition is we don't know the port. Okay, if it's a multi-source or a single source. So after performing this action A2, we'll know exactly if it's going to be a multi-port system or a single port system to transfer the coal. From this, we arrive at S2, that is known ports of coal. From this state S2, we'll now move on to next step S3. So S3 is what is known minimum distance source MDS with required quality and quantity. So the quality of the coal required and the quantity of the coal required, it has to be present at our minimum distance, the city or the center or the source which is at minimum distance from our state, that is Taiwan. So let's say from Kichung port, we have something that is very near. So we'll select that one as our next step. So we'll perform action A3 to find this minimum distance source. So the precondition will be we don't know what is the minimum distance source from us. So after performing this action A3, we'll get to know about what is the exact port from which we have to transfer the coal. So from state S3, that is knowing the minimum distance source with having the required quality and quantity of coal, we'll now go to S4 stage, that is ship reached at destination port. So the action we have to perform is we have to move the ship. Basically, we have to direct the ship from the minimum distance source to the destination port. So the precondition is that the ship is present at this source node, and the effect is that after performing the action A4, the ship will be present at the destination port, and that's it. So here we reach at S4, that is ship reached at destination port. So from this S4 stage, we have to now directly go to the SG, that is goal state. So yeah, we have to perform action A5, that is from port to plant. We have to transfer the coal. The precondition for this is the coal is at the destination port, that is the port where ship port, and it is not at the destination plant. So the transfer process takes place, and the cargo, that is the coal in this case, gets reached at the destination plant, and currently it's not at destination port. That's what we mean by these terms not of 80 and 80, the presence of coal. Yeah, so now we have reached at goal state, that is coal satisfied. Here you have represented as 80. Remember, in the beginning at SI we have represented it as not of 80, but here in goal state we represent it as 80, that is destination plant, because our coal has reached it. So that's it about states and actions. Now the next part is plan of plans. Over to you, Ankit.
Thank you, Gyan. So the heading of this slide looks quite interesting, right? So let me explain to you what is plan of plans. It is actually we are trying to plan out the plans that was generated for each and every of the 30 plants that require coal of different qualities and quantities. Can you go to the next slide? Okay. So what we did is that we performed a set of rigorous 5 actions for each plan to determine the to to find out a way of reaching the goal state of having the desired amount and the quality of coal that is required by a particular plant. So this problem is actually a bit complex because there are 30 plants, there are 3 ports and the 4 types of coal, and also there are the 25 different mining locations. So summing up all, we are actually choosing one of the optimum solution out of the 9,000 possible options that we have to choose. Uh, so these optimum path or the set of actions that we choose for a particular plant, uh, we actually have these information, right? So we have information about what path is being chosen for a particular plant, but we we haven't yet combined these plans. Like it may happen, like we can say that these data are unsynchronized. It may happen that two particular two plants, say plant number 8 and plant number 23, require a particular type of coal, say bituminous coal, in the same point of time. So what we can do is that instead of doing the allocation problem twice, we can perform a common type of allocation, that is, and hence we can minimize the cost. So can you move to the next slide? Okay. So here we have achieved the we actually have the plans that was generated initially for all the 30 plants, and and these are present in an uncoordinated way. So we have the initial state of uncoordinated planning, and we have to perform the action of synchronization or the coordination. And after that, we'll achieve the state of coordinated plan. Like we try to find out the intersections that are present for quality and quantity of coal, which are demanded by uh, different plants at the same point of time, so that instead of performing the allocation problems multiple times, we can sometimes minimize them, and hence we can minimize the cost of allocation and transportation. Thank you guys
Thank you.
for being a patient listener.
Thank you.